Atmospheric moisture. Water in the atmosphere exists in three states or phases. One phase is known as or called water vapor. The other two phases of water are the solid phases known as ice and the liquid phases known as water. Changing forms of water. Water changes form from one phase to another when heat energy is absorbed or released as shown in figure 1. Molecules of ice are held together almost stationary in a definite crystalline arrangement. However, when energy is absorbed by the ice, the molecules move more rapidly. They break from their fixed position and slide past each other in a fluid form of liquid. When more energy is absorbed by liquid water, the water changes from liquid to gas. Because the additional energy causes the movement of molecules in the liquid water to speed up, the molecules collide more frequently with each other. Such collisions can cause the molecules to move so rapidly that the fastest molecules escape from a liquid form to form visible water vapor in a process called evaporation. Latent heat. The heat energy that is absorbed or released by a substance during a phase change is called latent heat. When liquid water evaporates, the water absorbs energy from the environment. This energy becomes potential energy between the molecules. When water vapor changes back into a liquid through a process of condensation, energy is released to the surrounding air and the molecules move closer together. Likewise, latent heat is absorbed when ice thaws and latent heat is released when water freezes. Evaporation. Most water enters the atmosphere through a process of evaporation. Because the largest amounts of solar energy reaches the Earth near the equator, most evaporation takes place in the oceans of the equatorial region. However, water vapor also enters the atmosphere by evaporation from lakes, ponds, streams, and soils. Plants release water vapor into the atmosphere through a process called transpiration. Volcanoes and burning fuels also release small amounts of water vapor into the atmosphere. Sublimation. Ice commonly changes into a liquid before changing into a gas. However, in some cases, ice can change directly into water vapor without becoming a liquid. The process by which the solid changes directly into a gas is called sublimation. When the air is dry and the temperature is below freezing, ice and snow may sublimate into water vapor. Water vapor can also turn directly into ice without becoming a liquid. Light and water in the atmosphere. The interactions of water and light in the atmosphere can create a number of visual effects. When visible light passes through raindrops, the raindrops refract or bend the light rays, which separates the light into colors that make up the entire visible spectrum. You can see these colors in rainbows, glorias, and coronas. Coronas are small multicolored circles that surround the sun or moon. Glories are small multicolored circles that surround the shadow of an object in which light is shining. Sundogs, sun pillars, halos, and rings are caused by the interactions of light rays and ice crystals in the atmosphere. In general, ice crystals do not separate the light into different colors, so these phenomena involve white light. Sundogs are bright spots that appear in the sky, often on either side of the sun. Sun pillars are bright shafts of light that extend up and down from the sun or moon. Halos and rings are fuzzy or bright rings that are commonly seen around the sun and the moon. Crepuscular, sorry about that one, are slanting sunbeams that form when sunlight is intermittently interrupted by clouds or fogs. Clouds cast shadows that appear to break up the sunlight and to form smaller invisible rays. A mirage is one of two types of optical illusions that form when light rays are reflected as they pass through a boundary between hot air and cold air. The first type, called inferior mirage, occurs when light passes from a layer of cool air into a layer of air close to the ground. When the light rays enter the hot air, they bend upward and cause the sky to appear as a pool of water on the ground. Another type, a superior mirage, is an image of an object that seems to be suspended in the sky. This type occurs when light rays pass through a layer of warm air into a layer of cool air. When water comes in contact with dry air, some of the water molecules evaporate into dry air. The addition of water molecules in the air causes the air pressure to increase. This increase in pressure is due to vapor pressure. Humidity. Water vapor in the atmosphere is known as humidity. Humidity is controlled by rates of condensation and evaporation. The rate of evaporation is determined by the temperature of the air. The higher the temperature is, the higher the rate of evaporation is. The rate of condensation is determined by vapor pressure. Vapor pressure is a part of the total atmospheric pressure that is caused by water vapor, as shown in Figure 2. When vapor pressure is high, the condensation rate is high. When the rate of evaporation and the rate of condensation are equilibrium, the air is said to be saturated. The temperature at which the condensation rate equals the evaporation rate is called the dew point. At temperatures below the dew point, net condensation occurs in liquid water droplets form. Absolute humidity. One way to express the amount of moisture in the air is by absolute humidity. Absolute humidity is the mass of the water vapor contained in a given volume of air. In other words, absolute humidity is a measure of the actual amount of water vapor in the air. Absolute humidity is calculated by using the following equation. Absolute humidity is equal to the mass of water in grams divided by the volume of air in cubic meters. However, as air moves, its volume changes as a result of temperature and pressure changes. Therefore, meteorologists prefer to describe humidity by using a mixing ratio of air. The mixing ratio is the mass of water vapor in a unit of air relative to the mass of dry air. For example, very moist air in tropical regions might have 18 grams of water vapor in 1 kilogram of air, or a mixing ratio of 18 grams per kilogram. On the other hand, dry air in polar regions commonly has a mixing ratio of less than 1 gram per kilogram. Because this measurement uses only units of mass, it is not affected by changes in temperature or pressure. Relative humidity. A more common way to express the amount of water vapor in the atmosphere is by relative humidity. Relative humidity is the ratio of actual water vapor content in the air to the amount of water vapor needed to reach saturation. In other words, relative humidity is a measure of how close the air is to reaching the dew point. For example, at 25 degrees Celsius, air is saturated when it contains 20 grams of water vapor per 1 kilogram of air. If air that is 25 degrees Celsius contains 5 grams of water vapor, the relative humidity is expressed as 5 divided by 20, or 25%. If the temperature does not change, the relative humidity will increase if moisture enters the air. The relative humidity can also increase if the moisture in the air remains constant, but the temperature decreases. If the temperature increases as the moisture in the air remains constant, the relative humidity will decrease. Reaching the dew point. When the air is nearly saturated with a relative humidity of almost 100%, only a small temperature drop is needed for air to reach its dew point. Air may cool its dew point by conduction when the air is in contact with a cool surface. During the night, grass, leaves, and other objects near the ground lose heat. Their surface temperature often drops to the dew point of the surrounding air, which normally remains warmer when the surface near the ground air, which normally remains warmer than the surface near the ground dew, cools to the dew point when it comes into contact with cooler objects such as grass. The resulting form of condensation, as shown in Figure 3, is called dew. Dew is most likely to form in cool, clear nights when there's little wind. If the dew point falls below the freezing temperature of water, water vapor may change directly into solid ice crystals, or frost. Because frost forms when water vapor turns directly into ice, frost is not frozen dew. Frozen dew is relatively uncommon, Unlike frost, frozen dew forms near clear beads of ice. Measuring humidity. Meteorologists are interested in measuring humidity so they can better predict weather conditions. Relative humidity can be measured by using a variety of instruments such as a thin polymer film, cyclometers, a dew cell, or a hair hygrometer. Using a thin polymer film to measure humidity. Humidity is commonly measured by a humidity sensor that uses a thin polymer film. The relative humidity of the surrounding air affects the ability of the thin polymer film to absorb or release water vapor. The amount of water vapor in the thin polymer film contains changes in the film's ability to conduct electricity. The polymer's film's ability to conduct electricity is affected by the relative humidity of the surrounding air. Thus, by measuring the polymer film's ability to store electricity, relative humidity can be determined. Using cyclometers to measure humidity. A cyclometer, shown in Figure 4, is another instrument that is used to measure the relative humidity. It consists of two identical thermometers. The bulb of one thermometer is covered with a damp wick, while the bulb of the other thermometer remains dry. When the cyclometer is held by the handle and whirled through the air circulates around both thermometers. As a result, the water in the wick in the wet bulb thermometer evaporates. Evaporation requires heat, so the heat escapes from the thermometer. Consequently, the temperature of the wet bulb thermometer is lower than the dry bulb thermometer. The difference between the dry bulb temperature and the wet bulb temperature is used to calculate relative humidity. If there is no difference between the wet bulb temperature and the dry bulb temperature, no water evaporated from the wet bulb thermometer. Thus, the air is saturated and relative humidity is 100%. Other methods to measure humidity. Another instrument that is used to measure relative humidity is the dew cell. Dew cells consist of ceramic cylinders with electrodes attached to it and treated with lithium chloride, LiCl. When lithium chloride absorbs water from the air, the dew cell's ability to conduct electricity increases. By conducting the electrical resistance of lithium chloride as it is heated and cooled, the dew cell can determine the dew point. The hair hygrometer contains relative humidity based by the principle that hair becomes longer as relative humidity increases. As relative humidity decreases, the hair becomes shorter. Measuring humidity at high altitudes. To measure humidity at high altitudes, scientists use an electronic hygrometer. The hygrometer may be carried up into the atmosphere in an instrument package known as a radiosonde. A radiosonde is attached to a weather balloon, such as the one shown in Figure 5. The electric hygrometer is triggered by passing an electrical current through a moisture-attracting chemical substance. The amount of moisture changes the electrical conductivity of the chemical substance, the change that can be expressed as the relative humidity in the surrounding air.